In recent years, virtual reality has been applied in a lot of areas, such as movies, art and design, and gaming. While the immersive experiences and intuitive interactions are vivid for end users, designing and building VR applications can be difficult and frustrating because it requires knowledge of not only 3D modeling, but also computer graphics, imperative programming, and reactive programming. Now imagine building an interactive VR scene when you are immersed within VR. We present FlowMatic, an immersive authoring tool that allows novices to create reactive behaviors of virtual objects while immersed in the virtual environment. FlowMatic allows users to import primitive models as well as specifying their colors. They can also search for, browse, and import more complex 3D models on the fly from online asset stores like Sketchfab. Using FlowMatic, users can also position, rotate, and scale objects through direct manipulation. In FlowMatic, each model contains a list of attributes, such as color and position, that controls how a model is displayed, and a list of methods, such as animations, that shows the discrete actions that a model can take. Users can specify the relationship between elements by drawing edges with arrows indicating the directions of data propagation. FlowMatic also provides a set of programming primitives, such as operators, which transform and manipulate the data. A common limitation of the previous immersive authoring tools is that you can only see the model in your composition, but cannot specify how they should react to system events, such as user actions, object collisions, and system intervals. FlowMatic overcomes this limitation by integrating the concept of functional reactive programming, which allows users to declaratively program reactive behaviors by instantiating and connecting models, data sources, and operators in a visual flow-based diagram in VR. Let's use a simple example to illustrate the workflow and some unique interaction techniques of FlowMatic. Here, a designer wants to implement an interaction from Pokemon in VR, where the user throws a Pokemon ball and a Pikachu will appear with a smiley face. First, the user imports and arranges some static models in the scene. Then, she adds a create operator to the diagram to dynamically create a Pokemon ball whenever the user presses the trigger button on the controller at runtime. After the ball is created, she uses a translate operator to move the ball to a target position. She uses a cube as an abstract node, which is unique in FlowMatic. Using the abstract node, she can directly inspect and specify the parameters such as positions and scales of the created instances. After that, she uses another create operator to make the target character appear at the position. She can further add an animation to the character so that the Pikachu can animate after it's created. Users can test the application in real time when immersed in VR. Finally, FlowMatic also introduces a unique interaction for abstracting functionalities in order to reduce the visual clutters of the diagram. The self-defined function can update its input and output automatically during abstraction and can be saved for future use. We showcase the expressiveness of FlowMatic by replicating three relatively complex applications: a blaster game, a whack-a-mole game, and Beat Saber. Thank you for watching. Please see our paper and supplemental materials for more details.